Ladies and gentlemen, boys and girls, children of all ages, we continue to work on our multiplication. And I know you guys have already done these problems, and I know you already estimated, because you always want to make sure that your answer is reasonable. So I know that those of you who didn't just sit there and hope that the pencil wrote the answers on your paper by itself have already done the work. But let's start with an estimation. Remember, Kaylin, you estimate before you solve the problem. Otherwise, you're just rounding at your answer, and that's just cray-cray. So, Kaylin, I want to make this problem easy enough for me to do in my head. So I've got these two factors. So what could I do with these two factors, Kaylin?
So you can round the first number on top to probably 800.
Good, 800. That's a good choice. What would you do with the second number?
You would round it to 80.
I'd round it to 80. Good. Now, since we're multiplying a 10 times 100, that means our first number has to be in the hundreds place, which means I take these 3 zeros and move them down. Then all I have to know is I have to ask my good friend Kaylin, what is 8 times 8?
64.
Well, are you all named Kaylin?
Yes.
Wow, there's a whole bunch of you in here, Kaylin.
Yes.
64, thank you. So your answer should be somewhere near 64,000.
Yeah.
Now, if you got an answer of 528, you've probably done something incorrectly. Now, second thing I want you to think about is you can do this with one-digit division or multiplication. So I could multiply 793 times 7 and 793 times 70. Well, if I multiply it by 70, that just means I bring this 0 straight down because I'm multiplying a 10 by a 10. So if it's easier for you to only have to multiply to only see, because we're only multiplying by one digit at a time anyway, but to only see something here with one-digit factor, then break it apart like this. I'm just saying. And the way you could do that is let's just show you how it's done, folks. What is 7 times 3? 21. 21 ones. So we have 2 10s and 1 1. 7 times 9?
65.
63 plus 2 more is 65. 65 tens are 600s and 5 tens. And 7 times 7?
49.
49 plus 6, 55. Did I do something wrong? No?
I got a different answer.
Okay, 7 times 3 is 21. 63, 64,
Oh,
65.
wait, yeah, I got that. I was looking at the wrong one.
Oh.
Because you started it.
All right. So 793 times 7 is 5,551. Now guess what? Here, I'm multiplying it by 7 also. So once I put my 0 here, I'm going to have the same numbers.
So you get 5551. Okay, well then I did get it wrong then.
Well, because I'm multiplying it by 7. This time I'm multiplying it by 7 tens, which is why that 0 comes in. And once I do that, then I'm just multiplying 793 times 7, which is what I did here. So I should get 55510, 55,510. I didn't really even have to do that. So we multiplied this number by 7 both times. So you should get the same answer here, except this one's 70, so you put a 0 there. So if you got different answers for 793 times 7 and 793 times 7, then that's just cray-cray. I'm just saying it's cray-cray. Don't yell at me. I didn't make it cray-cray.
Oh, I know what I did.
Then I just have to add these two. Close your computers. Add these two products together. And then I get 1, and then I get 6, and then I get 10, and then I get 11, and I get 61,061. Is that right? All right. 61,061. All right, we can do the same thing on this other problem. Let's estimate this first. Dallin, I want to change these so I can do this multiplication in my head. So what do you think we can do with these to make it easier?
30 and 20.
30 and 20. Now we're not adding. We're multiplying a 10 times a 10, which means my first number is going to be in the hundreds place. So the way they explain it in little kid land is you just bring those two zeros down. But it's because you're multiplying a 10 by a 10. That's why the two zeros come down. And then all we have to know is 3 times 2, which is 6. So my answer needs to be somewhere near 600.
What? No.
It's going to be less than 600. Right? Yeah, because I moved this one up and I moved this one up. So it's going to be less than 600. It's like 25 or 15 people giving you a quarter. It's like getting 15 quarters. So you can probably figure that out in your head easily. Anytime I'm doing with 25s and 4s, I always think quarters, but that's just the way my mind works. All right, so now we can do 25 times 5, and we can do 25 times 10, which is the same thing you're doing on the regular problem. You just look at it and you're like, whoa, this is so much easier, dude. I'm just saying that's what you do, dude. All right, and actually this would be twice as big as this. Ooh, 5 times 5 is? 25. 5 times 2 is?
10.
Plus 2 is? 12. So you should get 125 here.
I did get that.
Now, I'm multiplying a 10 times a 10. So I'm going to have a 0 there. I got to start in my tens place. 1 times 5 is? 5. 1 times 2 is?
2.
Notice how if I multiply 25 times 5, it's half of when I multiply 25 times 10.
Oh, yeah. Wow. I had no idea.
And so now I'm gonna show you something interesting here in a minute with this whole times 10 thing. Okay? So 8, 5, 7, 3. So it is less than 600. And it's quite a bit less because we moved this up 5 and this up 5. So it is quite a bit less. But now, you've probably been taught since you were just wee little kids down here, that when you multiply something by 10, you just put a 0 behind it, right? Is that what you were taught? What were you taught then if you say no? When I multiplied 25 times 10, you guys just told me to put a 0 behind it, right? There's a reason why. There's a reason why. Now let's look at the number, and this is, I'm just adding this to the video, so you're getting free content here. Where is the decimal point in the number 25?
Behind the 5.
Behind the 5, because the 5 is in the ones place. If I multiply something by 10, I'm making it 10 times greater, so I move the decimal point to the right, one place, which means I need to have a 0 there, so that's why it equals 250. If I multiplied 25, and my decimal point's behind the 5, because the 5's in the ones place, and I multiply it by 100, I move my decimal point 2 places to the right. But what if I multiplied 2.5 times 10? What would my answer be? It would be 25. Because I'm just moving my decimal point to the right 1 time. So here you don't see the decimal point, but I told you at the beginning of the year, it's there. You don't always see it, but it is there. And all you're really doing is moving the decimal point to the right 1 place. Anytime you multiply by 10, it goes to the right 1 time. By 100, the decimal point goes to the right twice. By 1,000, it goes to the right 3 times. I mean, it's basically just the number of zeros that are there. But if we know our place values, that's why. Because we're making it 10 times bigger. And each place value is 10 times bigger. So we're making it 10 times bigger. All right, one other thing I got to show you for today's warm-up. Because you're going to see questions like this. And when I tell you to do the warm-up, which is a little bit because we got other stuff to do, when I tell you to do the warm-up, you're going to go, I don't get it. That's why I'm showing you this right now. So if we had 3 times 2 plus 4 equals G plus 7. And your question is, what does G equal? Let me show you how to get it. Because G does not equal 10. No, shh, listen. I'm going to show you how to get it. And then I'll answer questions. The equal sign means whatever I get here is got to be equal to whatever I get here. So the first thing I need to do is figure out what I get here. I always multiply before I add and subtract. So what's 3 times 2?
6.
6 plus 4 is?
10.
10. So 10 equals G plus 7. So what plus 7 equals 10? 3. So G equals 3. That's how it works. The equal sign tells you that both sides have to be equal. In order to make this side and this side equal, I have to make this side equal 10, because I know this side equals 10. To make this side equal 10, G has to equal 3. And you're going to get a little practice at that too. Boom, shakalaka, peace out, God bless, love you. Do something kind today. Please subscribe. Save the bees. Please subscribe and share.